Hey guys, welcome to day 24 of Codeforces Everyday until GM. Today I did 100 Codeforces problems, and here's what I learned video earlier today. So this is the second video of the day. Let me know if y'all like that one, if y'all want to see more videos like that. I do plan on doing like routine check-ins on how improvement is going and stuff like that. I know most of y'all don't watch the full like hour-long videos that I post every day, so it's a good way to, keep y'all guys caught up. For those who are just here to see the progress, So I do plan on posting those at like all the benchmarks or all the what's it called what's the word for it? Just like at 100 problems, at 1,000 problems, or maybe like every time I rank up in the contests, or I don't know, something like that. I do plan on doing like maybe like a 1 month special or like a monthly special video or something like that. Not too sure what the plan's gonna be in the future, but one thing is for sure is that you'll still be getting the daily video every day, and I'll still be doing problems every day. So yeah, that doesn't change. But I have been getting a lot of support in the comments. Been seeing a lot of y'all responding to like basically all of them. So if you ever want to ask me any questions or anything, leave a comment. I'll see it. You can even message me on Codeforces. I've seen a few people. I've responded to a few people on here already. So yeah, I guess without further ado, let's get solving. That intro gave me just enough time to clean my glasses, and then we can get started here. So, ultra fast mathematician. Ultra fast mathematician.py. Rating 800. Alright. This guy was an excellent student, great at everything, including combinatorics, algebra, number theory, geometry, calculus. Not only smart, but he was extraordinarily fast. He could manage to sum 10 to the 18 numbers. One day in 230 AD, trying to find out if anyone can possibly do calculations faster than him. As a result, he made a great contest. Each number is made of zeros and ones. Should write the new number. Real simple. The ith digit of the answer is 1 if and only if the ith digit of the two given numbers differ. What does that mean? In the other case, the ith digit is 0. So, okay. In a glance, he always gives correct answers. He won't give anyone very big numbers. Always gives, okay. Two lines in each input. Each contain a single number. Right output. Okay, so let's first just take an input. I should probably save it as a string because it has leading zeros. String input. Okay, so what's going on? Each pair is made from ones and zeros. New number corresponding to the given pair of numbers. The ith digit is 1 if and only if the ith digit of the two differ. So if they're the same, it's 0. Alright, so since these digits differ, same. So it's 1, 1, 1, 0. Okay, I get it. Yeah, this is pretty easy. So for I in range A len A if AI is not equal to AB. Let's track a 2 print equals this. Oops. If they're not equal, 2 print plus equals 1, else 2 print plus equals 0. Jeez. Print 2 print. Okay. String indices must be integers, not strings. So let's make these lists. Drover. Oh, B, I. Wait, I feel like, okay, they can be strings. There we go. 1110001. Yep. Should be 111. Yep. 0100. Yep. Then 00010. Yep. Okay. Pretty easy problem. Application or programming. Python. Codeforces. Ultra fast mathematician. Submit. Well, you got it. Another 800 rated. There we go. 233A. Perfect permutation. .py. Rating 800. A permutation, I know what a permutation is. Consistent n distinct positive integers, each doesn't exceed n. Yeah. He adores permutation. He likes some permutations more than others. He calls such permutations perfect. A perfect permutation is a permutation for any I following the following equation holds. PPI equals I and PI does not equal I. Any perfect permutation resides in given in. Okay. PPI equals I. What does that mean? So let's pull out the whiteboard, Excalidraw. PPI equals I, so it's like 1, 2, 3, 4, 5. I is the index. So PI, say I is 3. PI would be P3. So it's asking for P3. is just 3. And then pi does not equal to I. Switch over, because pi does equal to I in this case. So input is 2. So for 2, 1, pi, when I is 1, it's p of 2. Okay, I see. P of pi, so p of p2, which is p of 1, which is not equal to 2. I see. Okay, so n equals int input. And then we'll basically always output the same thing, right? If it's impossible, then it's always gonna be 1, 2, 3, 4 type thing. So if we just start backwards, like if we just do 5, 4, 3, 2, 1, does this work? So pp1 is equal to p of 5. Because p of 1 is 5, which is p of 5 is 1, which is equal to 1. So that doesn't work. Just flipping it doesn't work. Right, but then 1, 2, 3, 4, 5. pp1 is equal to p of 5, which is 5. So in the case 1, 2, pp1 is equal to p of 1, which is equal to 1. So that doesn't work either. Let's look at their outputs. They're 2, 1, 2, 1, 4, 3. So what if we like increment it? Like instead of 1, 2, 3, 4, 5, we do 2, 3, 4, 5, 1. P1 would equal to P of 2, which would be 3. Okay, that would work all the way to P5, which is equal to P of 1, which is 2, which is not equal I, which is 5. So I think this kind of equation would work, right? Let's just test with 2 or 1, 2 real quick. P1 is equal to P, or it wouldn't be 1, 2, it would be 2, 1, right? So let's test with 2, 3, 1. pp1 is p2, which is 3, which is not equal to. Okay, yeah, I think this works. So the formula is to print equals 1. Or, okay, to print equals empty. And then for I in range n to print, and we start at 2, stop at n plus 2, right, to print dot append I print, and then we do to print plus equals 1, to print dot append 1 at the end, then print to print hello to print. See what happens here. Huh? What's wrong with this? Okay, so that's not right. N is 1, so okay, that seems right. 2, 1, 2, 3, 4, 1. Okay, and then we need to do a check if n is equal to 1, print -1, else do this. Alright, now this is just assuming there's no other like cases where it's impossible. Because I think this is foolproof, right? 2, 3, 4, 1, 2, 3, 4, 1 PP 1 is P of 2. Which is 3. P2 is P of 3. All the way to P of 4 is P of 1, which is 2. So yeah, it's always P of I is equal to P I plus 1, which is equal to I plus 2, until the last case, which is just P of 1 equals 2. And technically it's PPN, which is P of 1, which equals 2. So yeah, this should work for all cases. Wrong answer, test 3. I'm actually quite surprised we ran into a Wrong answer. P1 equals 3 is not equal to 1. Wait, what? P of P1, P of 1 is 2. P of 2 is 3. Did I read the question wrong? There's multiple right answers, right? Okay. Hold that PPI. The following equations hold that PPI. Oh wait, a perfect permutation. A PPI equals I, and PI does not equal I. Wait, oh, PPI needs to equal I. I see. So PP1 needs to equal 1, but P1 cannot equal to 1. Okay, so this is a question misread. So P of 2 will need to equal 2, but P of 2 cannot equal to 2. So what does this mean? P of P. So P of P. Okay, so P1. Say P1 equals to 2, then P of 2 is equal to 1. Alright, P of P1 is 2, then P of 2 equals 1. So P of 2 is 1, and P of 1 is 2. So then what is P3? So P3 is equal to 4, and P4 equal to 3. PP3 is equal to P4. Which is equal to 3. Alright, PP3 equals P4. Which does not equal. Wait. And P of 3 does not equal to 3. Yes, that's true. So, is that the case? Is that just the case? Or it's P5 equals 6, and then P6 equals 5. P5. So, okay, so P5 equals P6, which equals 5, and P of 5 does not equal to 5. So what happens when it's a case like P2 equals P1, which is equal to 2, and P2 does not equal to 2. Okay, so P4 is equal to P4, or P4 is equal to P3, which is equal to 4. P4 does not equal to 4. Okay, so this is the pattern, basically. So I in range that's 2, 1, 4, 3, 6, 5. So counter equals 2. For I in range n, if I mod 2 is equal to 0. So if it's even, what do we do? Is 0, 1, 2, 3, 4, 5. If it's even, then we minus 1. So if it's odd, we do counter plus equals 1. If it's even, we to print dot append counter minus 1. Else we add 2 to counter, and we append that. Right. Print to print. So theoretically, if I had 6, it'd be, wait, what? Why does it start at 1? 1, 4, 3, 6. Should start at 2. 5, 0 mod 2 is 0, so 2 pin counter. Oh, I got these mixed up. 2 pin counter, and then counter plus 2. Else if it's odd, then we pin counter minus 1. There we go. So we do 6 now. Wait, this isn't right either. 2, 3, 4, 5, 6, 7. Counter starts at 2. Mod. Counter. Wait. If it's okay, if it's odd, we -1. Counter by 0. Counter plus equals 2, then append. Odd -1. Even. Counter plus equals. So, okay, so if this is 0 and we do counter plus equals 2, this should work. Uh, 6, 2, 1, 4, 3, 6, 5. There we go. So let's do star here. -1, easy. Oh, let's put this in here. -1, 2, 1, 2, 1, 4, 3. Wrong answer, test 4. Drover. I'm getting rolled by an 800. 2, 1, 4. Oh, so I also have to check if the input is a permutation. 2, 1, 4, 3, 6. Okay, so basically we can't do odd inputs. If in mod 2 is equal to 1, we print -1. Right, so if it's 5, it would be, we wouldn't have this one, we would have all these, but then it'd be 1, 2, 3, 4, 6. So, okay. Just double check everything else is still working. 2, 1, 4, 3, 6, 5, okay. There we go. This is why it's still good to do lower rated problems sometimes. But we're 33 minutes in, 2 800 problems down. Let's do a harder one. Oh, this one's a whole lot of yap. Jesus. 165A supercentral point dot pi. Rating 1000. One day Vasya painted a Cartesian coordinate system on a piece of paper and marked some points. Let's find the neighbors for some fixed point given set xy. Point this is xy's right neighbor if x prime is greater than x and y equals. Okay. left is if it's less, and lower. Okay, basically 2D array, right? Matrix. We consider the point from the given set supercentral if it has at least one upper, lower, left, right. So basically if it's surrounded. If the given point is surrounded, it's supercentral. Find the number of supercentral. Okay. First line is input in. And then the number of points in the given set. Next, in lines contain the coordinates of the points written as x, y without the quotes. All coordinates are integers. Okay. So for score in range in x, y equals map int input dot split. Okay. Guaranteed all points are different. Okay, so all of these are points, right? What is 8? First line, number of points given in the given set. Okay. So how do we track this? We just put them all in, and then we check. Okay, we can create a DIRS array. Or we can probably just shove all this in, like we can make it points. A tuple like this. Right, and then point dot append. Okay. X, Y, like this. And then print points. So this is our array of points. And then what does this do for us? For each point, okay, dirs equals just copy this. And then we iterate through for point endpoints. Okay, we can also define a super, what's it called? Super central. So 0. For point endpoints, for dr, dc, and dirs. counter neighbors equals 0 if point point O plus if point O wait if point O plus dr point 1 plus dc in points neighbors plus equals 1 if neighbors equals 4 super central plus equals 1. Okay, so at this point I'm just implementationing it. We're just checking each point. I'm not even sure if this works. It doesn't work, so might be this line. Okay, wait, let's use this one because it's shorter. And let's print out our current point. Okay, so our current 0, 0. We're checking 0 minus 1. 1. Okay. Here print neighbors. Oh, this ended up printing one neighbor. So this clearly ended up working somehow. Okay. 4 neighbors. So let's print super central at the end here. Okay. So we got 1. Now we're at 01. We check this. Doesn't exist. This doesn't exist. This doesn't exist. Or 0, 0 does exist. This doesn't exist. So super central. Okay, so this makes sense. So why is this failing? For sample, super central points are 1, 1, and 1, 2. So check 1, 1. 0, 1, yes. 2, 1 is not here. Oh, it's not just right next to, right? It's all of these. So okay, how do we do this? What's another way we can do this? So, okay, here's what I'm thinking now. We have this grid of like points. Let's do. I'm so artistic, I know. Here's our grid. And then we have these points. I don't think any of these are supercentral. Okay. A point is supercentral if, like, that's supercentral. Then I have another one here. So, in order for it to be supercentral, there needs to be one to the left and right, and up and below it. There also needs to be for DC enders. Okay, let's just brute force for now. For I in range uh what are I even in range? This isn't a good idea. I can't figure out a solution like this. So what is our current approach right now? We are so what if we create a dictionary of points? And hold on, I don't know. I'm gonna get some water. Be right back. Okay, so dictionary of points. And if I'm thinking like LeetCode 1 right now. It's like point as a tuple and then a list of like false, 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 for like up, down, or like left, right, up, down, left, right. And then every entry, every point, you check you iterate through like the keys, and then you check off one of these if they are in the same row, and then you just append. You check off these for this and the new point. Maybe that would work. We can try it. So points is a dictionary for I, or for blank in range in for key endpoints dot keys for key endpoints dot keys if x, so if x is equal, then y is different. Let's just do up, down, left, right. So if x equals key then we're looking for, if the x is equal, then we're looking for up and down. Points key then we check if they're the same, then if y is greater than key 1, do this. If y is less than key 1, do this. If y is greater than key 1, then points key 0. Y is greater than key 1. Y is greater. If it's less than, if y is less than key 1, then points key 0 is equal to true. Key 1. If y is greater than, okay. And then it's the opposite if y is equal to key 1. If x is less than key 0, points key 3 and 4 equals true. And then at the end, we just iterate through points for points in points dot items. Can I do for points and points? Okay, for key and points dot keys. Super central equals 0. If points key is equal to true, 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 super central plus equals 1, and print super central. Okay. Assuming that everything's working correctly. Okay, something's definitely not working correctly. So we are not appending 2 points. For key endpoints, key new list is equal to false. False, false, false. New list up. So new list down equals true. And new list up would equal to true here. And then new list right, new list left would equal to true. And then at the end, we would points x, y equals new list. There we go. Jover. List assignment index out of range. 0, oh, 1, 2, 3. And this one's 3, 2. 1, 2. Oh my god, it worked. That's crazy. Let's see if it accepts it. Wow. I can't believe that worked. Isn't this glorious? My if statement conglomerate. Let's see how they do it. Super central point. Should just code what was written in the problem. Okay, that's exactly what I did. Consider every point consecutively. Find neighbors from every side. Yeah, that's exactly what I did. Okay, cool. I'm glad that was the solution. Implementation was not even that tricky. It was just coming up with it. So, yeah, should we do another? It's already been an hour. We have enough time for another, or maybe an easier one. Let's just do the next one here. 800 rated. Shouldn't take us too long. Just filling out the ladder, you know? Okay. Arrival of General. 144A. Arrival of the General. Control C. Rating 800. I did say I would do less 800s and move on to harder problems, but a defense, blah blah blah, super secret military squad, having news, colonel ordered to all in squad soldiers to line up on the parade ground, By the military charter, the soldiers should stand in the order of non-increasing of their height. No time to do that. Lined up arbitrarily. Short-sighted, line up correctly if the first in line has the max height and the last has the min height. Okay. Please note that the positions do not matter. Only the heights of first and last matter. So this is correct, this is wrong. Okay. Within 1 second, Colonel can swap any two neighbor soldiers. Help him count the minimum time needed to form a lineup he will consider correct. Okay. Okay, so given this, we require 2 swaps. Given this, we require 1. Okay, so it's 1 swap, 2 swaps. Or what's the greatest? This is the greatest. This is the least. So it's 1 swap, 2 swap, 3 swaps, 4 swaps, 5 swaps, 6 swaps, 7, 8, 9, 10. Okay, I get it. So input and then we're given a list. Okay, just write it then. A equals list map int input dot split, and then we need to get the index of the max value in the array. We need index of max and index of min. So we can do a max equals max a, and then a min equals max or min a, and then we can do a max index equals a dot index of a max, and then we do the same for min, a min. And then first index. Okay, so returns the first index of value. How do I return last index of value? I have to reversing the list. Okay. Okay, so what we can do is len a minus 1 minus a negative 1. Does work? Let's do this one. Print a max index, a min index. 6 and 0. So here's 0. 1, 2, 3, 4, 5, 6. Okay. So what actually needs to happen is we swap these. A max. Because this is more interesting than this to us. Right? 1, 6. Yes. Now which swap do we do first? Swap, 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 swap. We should always swap the further first because it doesn't matter actually. So what are the cases if it's okay? So what we want is max, min, and then what we can have given to us is worst case. Worst case, it doesn't matter which side we swap first. Then we have which it doesn't matter which side we swap first, right? Because of this and then this. We'll move this way. So it doesn't actually matter which side we swap first. Right, and the last case is like so what's the formula? So if they don't cross over each other, it's edge minus n plus edge minus this if they don't cross over. If they do cross over, it's edge. Alright, let's call this left and right. So it's if they don't cross over, it's right minus small m plus left minus big M plus big M minus, it's just plus big M, right? Because it's 0, 1, 2, 3. So 0, 1, 2, or 1 swap, 2 swaps. Big M minus 1. Wait, then right would be 1 swap, 2 swap, 3 swaps. Feels like it's 3 swaps. R would be 4. M would be one swap, two swaps. So M here is 3. So R would be 4. One swap, two swaps. Okay, so this is correct. So if they don't cross over, it's this. If they do cross over, it's R minus M plus M. So like M will be here, and it's 1, 2, 3, 4, 5. One swap, two swap, three swap, four swap, five swap. M's here, which means M would be 6. M is 7, M is 6. Still be minus 1. So just the same equation. So, okay, in this case, 1, 2, 3, M is 3, 4, 5, 6, 7, 8, 9, 10. Right is 10. So it's 10 minus 7 plus 3 minus 1, which is 3 plus 3 minus 1, which is 7. This requires 7 swaps. This requires 7 swaps as well. We do 1, 2, 3, 4, 5, 6. No, this isn't correct. This is 1, 2, 3, 4, 5. This should be 5 swaps. Why is it 7 swaps? This is 1, 2, 3. So this is correct. 1, 2, 3, 4, 5. Oh, am I retarded? It's minus 1. This is 5. So this is correct. So 1, 2, 3, 4, 5. That's correct. This should be 1, 2, 3, 4, 5, 6, 7 plus, this is here now, so it's 1, 2, 3, 4, 5 equals 12. According to the formula, it's 10 minus 3 plus 7 minus 1, which is equal to 7 plus 6, which is equal to 13. So we just add a minus 1 at the end. So basically, if they intersect, we get minus 1 more. So, okay, so if A max, okay, so swaps 0, okay, if A max index is greater than A min index, swap equals -1, else swaps equals 0, and then swaps plus equals R, which is len, which is n. 1, 2, 3, 4. So it's n minus m plus m minus 1. Print swaps. Three, over. So this is scenario A max, A min. So swaps equals 0. And then n is 4 minus min index, which is 3. I should probably print all these. Print n a min. And okay, a swaps a min index, a max index. Four swaps is -1. That's not right. A max index. If a max index. Wait, what? Why is it -1? A max index is 0, 1. A min index is max index, a min index. It's because these are flopped. A min here, a max here. So a min is at 1, a max. Okay. 4 swaps is 0, 2, 1. Okay, that seems right. 11, over. We have 7. Start at -1 because max is to the right of min, which means they cross over. So that's correct. And then, so this is what's wrong here. We grab the first index of min when we should be grabbing the last index of max, or of min. So, okay, so these need a swap, basically. A dot index max. We want the first iteration of max, a max, and the last iteration of a min. Okay, so that's what I messed up earlier. There we go. -1, grab this one, and we'll grab this one. Okay, this should work. Check. 10. Yep. Arrival of the general. There we go. Perfect time to end this video. We did, how many questions did we do today? 4? Pretty good. 3 800s, 1 1000. Some of the 800s were quite tricky. Like this last one took quite long debugging it. But yeah, I'll be doing harder questions soon, hopefully. We got a few level 1s to go through. 1, 2, 3, 4, 5, 6, 7, 8. 8 level 1s left. Hopefully I'll get through some of these in my free time as well. And we can head on to level 2s. We'll do level 3s every once in a while too. But yeah, if you like this video, be sure to like and subscribe, and I'll see you guys tomorrow.